welcome everyone to this talk. Thank you for coming. It's a nice weather outside, so I'm really happy that you're here instead of enjoying the nice weather outside. This talk is a bit different than some other talks at this conference because it's also about infrastructure security instead of application security. However, these things are converging, as I will show in this talk, and I will show that software-defined infrastructures do have many advantages in terms of security, but things can go also wrong. So if you don't do things correctly, then things can go horribly wrong. My name is Theodoor Scholte, and I've prepared this presentation together with my co-worker Thomas Kraus. He's our expert on Puppet and infrastructure as code. Unfortunately, he could not attend this conference because he had other commitments. So let me introduce a little bit myself. I'm a software security consultant at the Software Improvement Group, which is an Amsterdam-based consulting firm focusing on software quality. We look at systems from different angles. We look at maintainability, but also security. And we see a lot of different systems every year, and also software-defined infrastructure systems. So that's probably why I'm here today. So we conduct secure design reviews, secure code reviews, and in my spare time I really like to hack and code. Previously I was employed by SAP, the German ERP manufacturer. I was a member of the product security response team. And I was responsible there for handling security issues and rolling out security patches to SAP customers so that customers could run secure SAP solutions. I also used to be a security researcher, and I've got a PhD in web security. And in my spare time, I also like to actively work on mitigating risks, although not security risks. With more safety risks I like to climb. But actually I'm really interested in who are you? So who of you is operating in a software-defined infrastructure, is using Puppet, this kind of stuff? Who is here? Who is working here with security? Did more people? Good. And who is concerned about security? And who is concerned about the security of their SDI? Good that you're here today. So let's continue. First with explaining classic infrastructures. Well, traditionally, a system administrator had to deploy a system manually by getting a piece of bare metal, installing an operating system on it, then installing different services on top of it, so a web server, DNS server, then he had manually to deploy a web application on that web server, and so on. Well, you can imagine that this is a lot of manual work and this does not scale. He needs to install every time individual servers, and imagine if you have to manage thousands of servers, that doesn't work. But there's also poor testing abilities. It's pretty difficult actually to set up a completely exact environment and then do testing on that infrastructure. And with manually configuring servers, it's also really hard to track changes, right? I mean, a system administrator manually reconfigures the system. And after a reboot, you may imagine that after a reboot, certain settings have been changed and you are not aware of, and then the system fails. And that's a problem. Well, with software-defined infrastructure, everything is your system configurations, and what you run on the system is defined in code and in configurations, and then this code and this configuration is stored ideally in a version control system, such as SVN or Git, And then you have tools that allow you to run the code. So Puppet, Chef, Ansible, Terraform, these tools. And by executing the code, you either get an n number of new systems, or you get an n number of refreshments of the configuration settings. And what's really important to note is that, since it's actually software development, building up an infrastructure, it's just software development, building and maintaining an SDI. So you need to establish requirements, design and engineer the solution, define what is generic functionality, what is specific functionality. You need to write maintainable and secure code, and you need to do testing. So how does an SDI look like? So key elements in a typical SDI architecture are a provisioning system and the configuration management system. The provisioning system pulls a piece of code in configuration from the version control system. It uses that code to invoke a cloud API, such as the API of Amazon AWS or Heroku or Google Cloud. And by invoking the API, the administrator can spin up a number of instances. Well, an instance runs an agent, a configuration agent, which pulls the configuration for the machine and the code from a configuration management system, and the configuration management system pulls it from the version control. There are many different variations of this architecture. So sometimes configuration management and provisioning are combined in one system. So you have a typical setup can be that you have Puppet for both configuration management and provisioning. Sometimes different tools are used. For example, Terraform for provisioning and then Puppet for configuration management. And another variation could be that you don't have a centralized configuration management system, but you have it installed locally on your instance, and you're yourself responsible for distributing the code and configurations to the instances. So there are clearly some different variations of this architecture. SDI has many advantages for security. So first of all, you can define a security baseline for a machine, and then deploy that multiple times, and then you can build a secure baseline and enforce common security settings everywhere. So, like for example, disabling the SSH2 protocol on all machines. So that's a nice thing. You can configure security rules based on the role of the machine. So, for example, if you have a database server, you can say, like, okay, for all database servers, I only want to have the firewall port open for the database server. You can do automated security and compliance testing of all your systems with tools such as RSpec, ServerSpec, or InSpec. There will be an excellent talk on this subject by Christoph Hartmann later in this conference. And you can also deploy security patches faster. Since everything is automated, you can have faster recovery after compromise of a machine. And you can demonstrate compliance, because with version control, you can you can determine who changed what configuration and which changes were made to the configuration. Unfortunately, SDI is also a very powerful instrument. It is used actually to configure and run your infrastructure. It's really, really a core thing. So I sometimes say that, so you run everything from a single code base, and sometimes I say SDI is like a baby with a chainsaw. It's a very powerful instrument. And then the challenge becomes like, how to prevent that the SDI itself becomes the attack factor. That's what I'm going to try to answer in this talk, by showing a number of common security issues that are typically overlooked after observing after analyzing a number of software-defined infrastructures in the past few years. So let me go back to this this overview of an architecture of a software-defined infrastructure. Basically, there are three things that I want to focus on in this talk. It's insufficiently protected interfaces of the code and configuration management system, and the cloud APIs, insecure handling of secrets, and remote code inclusion. Of course, this is non-exhaustive. There are a lot of other things you have to do to make a secure SDI. Of course, you need to harden the configuration management and the provisioning environments. You need to do server hardening on the instance. But yeah, due to the time, I can only focus on these three issues. So what I've discovered in a couple of assignments related to SDI is that that interfaces of the code and of the version control systems and the cloud APIs are often insufficiently protected. So we found that the cloud API is invoked with root accounts. The code and configuration repository doesn't have authentication, no access control, weak passwords, or no role-based, no access control on it. And yeah, the argumentation is like, this version control system, it's just a backend system, so we don't need to secure it. Well, of course, you have the insider threat that someone, some malicious user in your organization or a disgruntled employee, wants to do bad things and changes system configurations, can steal. But you can also have external entities like external attackers that try first to compromise an instance, and by after having compromised the instance, the attacker then tries to make changes in the version control system. And since that the code in that version control system is used to configure and run your infrastructure, the guy might steal cloud capacity, get access to production data, manipulate the infrastructure, including shutdown of resources. All this kind of bad stuff can then happen. Well, a third issue is insecure handling of secrets. So one of the primary strengths of a configuration management system is that it works with reusable code. So code that has many purposes also needs to be configured. And in a typical code base, you find modules for each different application running on an instance. So for example, you have for MySQL, you have then a module for let's say installing MySQL, and then also a piece of configuration for configuring configuring the MySQL server, for example, the number of maximum allowed connections, the port number the server is running on, and all this kind of stuff. So specifically, if you focus on Puppet, you have URA data, which is the configuration data. Configuration settings are expressed in URA data and YAML files, and Puppet, the Puppet code is then stored in manifest files. And what we often see in our design and code reviews is actually that the configuration file just contains password. Like this is an example of an anonymized example where of a configuration for a web application which accesses a database server, and this configuration file just contains the clear text password to access that database server, which is really a bad thing. Because it's just like writing a password on a piece of paper, putting it on your machine, on your next to your keyboard, to remember your password. But with configurations in SDI, these sensitive informations, these credentials are stored in version control. Many users do typically have access to this version control system, and it also maintains a long history. So yeah, it's a really bad thing. And fortunately, there exist solutions to prevent that. So one way to do that is encrypt configuration values. So with Puppet, configuration values are stored in the Jira backend, and for Puppet there exist multiple different backends. For example, a REST backend, but also a YAML file backend, a REST backend, MySQL, PostgreSQL backends, and you can also write your own custom backend. And there also exists a backend for storing encrypted configurations settings, which is called the YAML backend. So then the idea is actually to store to create the database passwords and encrypt it using the private key that's installed on the configuration server, using the public key, sorry, to encrypt the configuration. And then you can store it to version control, and the configuration management tool can decrypt it up on the fly when there's a configuration change. And this password is then transferred to the instance using a TLS protocol. So that's a way to deal with secrets. But then there's still the issue that a lot of configuration management tools actually log configuration changes. So if a configuration change, if the configuration on a particular instance changes, then the changed value is logged, and this is a problem if the configuration file contains a secret, like a database password. And what you see typically in logging setups is that the logged information ends up in many places in the end. So first it's going to SysLog and then to your SIEM system, and then you don't have any more control over where your logged information, where secrets ends up. So you need to be very careful with logging configurations, with logging changes of configuration files. Fortunately, also many configuration management tools have ways to avoid logging of configuration content. In any case, having credentials of services in your configurations has also a number of other challenges. Like what you typically want is actually that you rotate the credentials, right? I mean that you over time, that for example the database account on the database server, that the password is not, it changes over time. Many organizations do not have a policy for that, or they do have a policy, but then the change process is actually very complicated, resulting in that the passwords never change. So one way to avoid that is using actually is to avoid long-living credentials altogether with dynamic credentials, and servers such as a HashiCorp Vault can do that. It creates a sub-account with credentials for particular servers like MySQL, PostgreSQL, but also Amazon and AWS is supported. Then these credentials expire after a lease period, and it also means that the credential needs to be renewed on time, because if it's not renewed, then that leads to authentication failure, and then your web application making use of a database account doesn't work anymore. So for that, the control flow of, let's say, updating those passwords is typically incompatible with configuration management tools. So you need a separate process on the instance to update these passwords and configuration files. And the tool to do that is console template. Well, the third issue that is quite common is the inclusion of untrusted code. Strictly speaking, Docker is not necessarily part of an SDI, but it's often used in combination with an SDI, and it's a container technology, right? So with this technology, you can deploy applications in containers, and to do that, Docker uses to build Docker images, to build these containers. Docker reads and executes instructions from a Docker file. And this is an example actually from Docker Hub. Docker Hub is a let's say an ecosystem, a platform where you can where you can download Docker files which setups then a container for you. And if you browse through Docker Hub, what you then come across is like this kind of files where an install script is just downloaded using curl, then it's piped and executed. And how do you know that this? How can you trust this? How can you trust this web server that it has not been compromised, that the install script has not been altered by a malicious user? So there's no way actually to do a verification on, for example, checksum to check for the integrity of the installer or the packages, like what you normally do have with Ubuntu packages, Debian packages, but also build management systems, dependency management systems like Maven do that have that. So this is really an example of convenience over security, right? It's really easy to just download the script from the internet and execute it. Well, fixing SDI security structurally. Well, as I said earlier, developing and maintaining an SDI is really like normal software development. What you also have seen in other talks is the concept of a secure development lifecycle, which is essentially a software development lifecycle with the usual steps like establishing requirements, doing design, coding, verification, with the addition of certain security activities, and establishing security requirements, threat modeling activities, code reviews, security testing. And to address SDI security structurally, your secure SDLC also needs to cover your SDI instead of just your normal web applications. So one interesting thing to look at is code review. With code review, you can kind of analyze the code and find security issues. So here are a few examples which you can use to detect remote code inclusion, too permissive file permissions, passwords and secrets in files. What is important is that you do not only need to look at your own code that you have written yourself, but also code by external parties, provided by external parties. So you have these ecosystems where you just download, where you can install pre-configured, or not pre-configured, but you can install, you can download modules from, code modules, Puppet Forge, Chef Supermarket, Docker Hub. And you either need to trust them or you need to review the code to detect security issues in there. So to summarize, I'm running out of time. SDI, it has many advantages to improve the security of your landscape. It can also become an attack vector itself if not done properly. Common security issues that are typically overlooked are, of course, great access control or insufficiently protected interfaces, insecure handling of secrets, remote code inclusion, and to address security structurally, you need to include it in your SDLC. Thank you very much. Yeah, are there any questions? Yeah, have time? Yeah. Yeah.
Are there any
Yeah, there are a number of tools. So one of them is Git leaks for that can analyze automatically Git repositories. Well, the interesting thing is that all these issues are pretty simple issues, right? I mean, you don't need a full-blown static analysis tool to detect them. So yeah, another thing actually to check, let's say, the hardening of your infrastructure is to make use of InSpec, which is a testing tool for Chef. And yeah, there will be a tool. There will be a talk about that later on in this conference. Other questions? Okay, thank you very much.
Thank you very much.